This is my AI assistant Ada, and she could do a lot of cool things, whether it's controlling my home, doing some shopping for me on the web, or a whole lot of other stuff. But Ada does have one big problem. Every time we ask her to do something, she needs to operate on Wi-Fi. So she sends out a prompt to Google's big data centers. We have to wait for a little bit, and then we eventually get a reply back. The problem with this is, one, she needs the internet to work. Also, our prompts are not private. And lastly, if you use this enough, it ends up not being free anymore and you have to pay. So today we're gonna make a new AI assistant that's 100% local, 100% private, and 100% free. So the first step in building our AI assistant is picking an open source model. So I started with these three choices: Gemma 3, Qwen 3, or DeepSeek R1. And each of these three open source models comes in different sizes, which are measured in parameters. In most cases, the more parameters a model has, the smarter it is. But also, the more parameter a model does have, the more resource intensive it's gonna be. So a very rough estimate is 1 billion parameters is equal to about 1 gigabyte of VRAM. So to start off with, I decided I'm gonna pick a model between 1 billion and 2 billion parameters. And that's because my GPU only has about 8 gigabytes of RAM. And if you take away the RAM that my operating system already uses, we only have about 6 gigabytes of RAM to work with. So you have to be very strategic on the models that we're choosing. So these are the three models and sizes that I want to test. So I went ahead and wrote a test script that's going to test the model in 4 different areas. And we're going to be measuring accuracy, how much VRAM the models are taking up, and lastly, the latency, how long we have to wait before the model starts typing up the answer. Okay, so after running the test, the results are kind of weird. So first, each model performed great for accuracy. All of them scored 90% or higher, with Qwen 3 scoring the highest with 95%. But also Qwen 3 being the largest model, it took almost 2 gigabytes of VRAM. And with Gemma 3 and DeepSeek, only a little more than 1 gigabyte of VRAM. But what really surprised me was the latency test. DeepSeek and Qwen both took about 100 milliseconds, but Gemma 3 took twice as long, which is a little weird just because it's a smaller model. I would assume it would be the fastest. But with that, it really cuts down on options to either DeepSeek or Qwen. But one cool thing about DeepSeek and Qwen is that they're both thinking models, which means that they could kind of think through problems. So I'm curious to see how each of those models will perform if I run the same exact test, but with thinking on. So after running the test with thinking on, both models did perform better on accuracy. Qwen scored 100% and DeepSeek got one more question right with 95%. But the main downfall of using thinking is how long it takes the model to respond. It took Qwen 3 1700 milliseconds to respond back, and it took DeepSeek 1900 milliseconds to reply back. But in comparison, Qwen 3 performed better on accuracy and is faster, so that's going to be the model that we're using for this project. But now we kind of have a problem. Are we going to use Qwen 3 with thinking or without thinking? But I thought about it and I said, why not use both? So we could first send the user's prompt through a small quick model, and that quick model then decides to send it to either the Qwen version that is thinking or the Qwen version that is not thinking. And at first I thought I came up with some new brilliant architecture for AI, but I did some research and this is just called routing. You have one AI that is smart enough to send specific prompts to a more specialized AI model. And thankfully, I already have a model in mind to do the job, and that's Gemma. We're not using any version of Gemma. We're using a specific version of Gemma called Function Gemma. And what makes Function Gemma so special is that one, it's super small, only 270 million parameters, and also it was specifically trained to output functions. And if you don't know what a function is, it's just a tiny snippet of code that can be ran to execute a task. So first, to get a baseline, I wrote a script that's going to test the model on about 21 different variations of whether to think or not to think. And I'm not expecting it to do well because in the model's documentation, it says you are supposed to fine tune the model on your own actual functions. So let's just see how it does. And okay, to no one's surprise, the model performed bad as we expected. It scored a 52%, getting 11 out of 21 questions right. And the average routing time was about 1700 milliseconds, which is pretty slow. So now we're going to train the model. So basically you gather a whole bunch of examples on what your input is and what the model should say. I did that with a total of 200 examples, 100 for non-thinking, 100 for thinking. We're going to train the model on this, and then we're going to see how it does. So the trained model did a lot better. It scored a 95%, getting 20 out of 21 right. And also the average routing time was 1000 milliseconds, which is pretty fast. So if we do a quick VRAM check, we know our operating system takes about 2.1 gigabytes of VRAM. And now with Function Gemma combined with Qwen 3, we're using another 2.3 gigabytes of VRAM, which means we only have about 3.5 gigabytes of RAM left. So we're starting to cut it close. And we still need to be able to speak to it and for it to speak back. So let's set that up. Well, first, let's handle text-to-speech. And the model that we're gonna use for this is called Piper TTS. And what makes Piper TTS so good is one, is ran on the CPU, not the GPU. So we can run this and it's not gonna slow down our Qwen 3 and Function Gemma. But also, usually if you run a model on your CPU, it's slow, but Piper is insanely fast. So if we go ahead and run our demo file, let's just say type in hello and let's see.
Hello.
Okay.
How can I assist you today?
That's pretty fast. Let's ask a little harder question. Let's see if it thinks. Explain inverse kinematics. All right, we see the thinking coming up. Perfect.
Inverse kinematics is the process of determining the joint angles of a robotic arm or mechanism required to achieve a specific end effector position and orientation.
Okay, so it's fast. The voice sounds half decent. I mean, we're working with what we have. So now we need to add two things. We need to add a wake word, and we also need to add speech to text. So if you guys are watching the channel for any amount of time, you will know my go-to wake word is Ada. But in order to do this locally, I'll have to train the speech to text model on me saying Ada a trillion times. And honestly, I really don't want to do that, especially because all my code is open source. As soon as I release it, you guys always ask, how do I change the wake word name? Does the name have to be Ada? So instead, we're going to use a pre-trained model that uses a wake word that hopefully everyone is happy with, which is Jarvis. So the way this is gonna work is that as soon as I say Jarvis, the wake word model is gonna flag the speech to text model to start converting my speech to text. Once that speech is converted to text, it's gonna go to Function Gemma. Function Gemma is gonna say, hey, is this a thinking question or a non-thinking question? It's gonna send that to Qwen. Qwen is gonna give us our answer, and that answer is gonna be converted to speech. All right, so we activated speech to text, and I'm talking. As you can see, nothing's happening. But as soon as I say, Jarvis, how are you? It listens.
I'm here. How's everything going?
Beautiful. Jarvis, explain AI to me. It does the thinking.
AI, artificial intelligence, is a technology that allows machines to perform tasks that would typically require human intelligence, like learning, reasoning, or problem solving.
All right, so it works, and it works pretty well, but there's no user interface, there's no GUI. If it was up to me, I would have just reused my Ada GUI, but we have a problem. We're already using 56% of our RAM, and the Ada GUI is very, very resource intensive. It's completely modular, has a whole bunch of animations, it has hand and gesture control. It's just too much for a local AI. So we're gonna remake the GUI with the focus on one, being lightweight, and two, having a lot of features that Jarvis can directly interact with. Also, if you guys have been liking the content, make sure you like the video. And if you wanna see more of this type of stuff, subscribe to the channel. So when designing the user interface, the first thing I thought about, what are the daily tasks that I struggle with that I'm gonna need help with? And the first thing is obvious, I suck at planning things. So I split the planning tab up into multiple sections. The first, a regular to-do list. So let's say if I need to do shopping, I can add that to my to-do list. I could complete it. I could uncomplete something, and I could also delete. The next thing that I wanted to add was just adding things to calendar. So you have your calendar, and then let's say dinner. We set the time for later in the day, set it. We say it's personal, and boom, we have dinner. Then the last two things is pretty simple. A simple timer, and then also set an alarm so I can wake up in the morning. The next thing I wanted to add was just keeping up with news and current events. So I wrote a custom script that runs in the background, and it checks for news, and it also pulls the top 10 or so headlines. And then of course I made sure to add smart home control so we can turn on and off the lights and also change the colors. So now our UI has all this functionality, but how do we get Jarvis to control it? And that's honestly the easy part because we already done it. So originally we trained Function Gemma just on two functions, thinking or non-thinking. But what if we trained it on turn on the lights, or add this task, or add this event to my calendar? So I put together about 10 functions, for me to retrain function Gemma on so it can have complete control over everything that the UI could do. So let's put it all together and let's test it. Jarvis, add buy groceries to my to-do list.
Add buy groceries to your to-do list.
Nice. Jarvis, set an alarm for 8 a.m.
Alarm set for 8 a.m.
Jarvis, set a timer for 1 minute.
Timer set for 1 minute.
Jarvis, anything important happening on the news?
The top news includes Trump's potential visits to Denmark and 7 countries, a red purple star sapphire from Sri Lanka, a fraud scandal, and ICE unrest impacting 2026 races.
Jarvis, can you go ahead and turn off the lights in the office? Nice.
I'll turn off the office lights.
Nice. Jarvis, can you turn on the office lights?
I'll turn on the office lights.
Jarvis, change the office lights color to blue.
I'll change the office lights to blue.
So those are the main features. Also, the one thing that I really wanted to add that I just could not get to work was the browser agent. But if by any chance you are interested in the browser agent and you want to see it working completely, doing some shopping for me, doing some research for me, you can check out this video of Ada because the browser agent is working perfectly there.